What is game theory? It is the study of strategic decision making where situations are referred to as games and participants as players. It is said to be based on the idea that interactions are not usually associated with the games, such as a business competition, war, and elections. It could also be treated and analyzed as games. Have you ever thought of the games you play, like board games and mobile games? It's acted out by people. They play it. Game theory's application is quite broad. It is used in economics, political science, and psychology. Real life examples include competition among companies, negotiating international treaties, voting in elections, and so much more. A game consists of players, actions, and a payoff function for each player, which would depend on their decisions. Actions of each player are called as moves, and a sequence of moves are called a strategy. Games can be illustrated in two forms: normal, which is represented on a table of numbers, and strategies listed along their payoffs, and extensive, which is shown in tree diagrams and branch points. Both are considered games, but are an alternative way of looking at games. Both could be applied to any game. A famous game that I'm sure you're not familiar of is The Prisoner's Dilemma. The scenario is two suspected felons are caught by the police and are interrogated in separate rooms. They were told that if you both confess, you will each go to jail for 10 years. If only one confesses, he'll get 1 year and 25 for the other one. If no one does confess, both will get 3 years in jail. The prisoner's dilemma in normal form will look like this. It is the table presented at the PowerPoint. As you observe, the payoffs are in the cells, which indicate that if the first prisoner confesses, the second will also prefer to confess their crime. If the prisoner would not confess, the second prisoner would certainly prefer to confess. In this, the goal is not to win, but to identify his own strategy. May it be ending up ahead of another player is of no consequence. But the concern in this is whether the optimal strategy would be used. Simultaneous games are also known as static games. They stand as a fundamental concept for analyzing strategic interactions among players. Unlike sequential games, where players make decisions sequentially, in simultaneous games, players act at the same time or simultaneously. They are unaware of their actions chosen by others. The game is made more intricate and intriguing by the lack of knowledge regarding the decision made by other players. A dominant strategy is a strategy that consistently yields a higher payoff than any other strategy for a particular player, regardless of the strategies chosen by other players. In simpler terms, a dominant strategy is the always best choice for a player. Take the prisoner's dilemma scenario, in which two inmates must choose between confessing and staying silent. Confession is a dominant strategy for each prisoner since, independent of the prisoner's decision, it assures a higher reward than staying silent. Identifying dominant strategies simplifies decision making for players, as they can confidently choose the superior strategy. Each player has one strategy, and the Nash equilibrium is a set of strategies where each person's plan is the best way to counter the strategies of the other players. Stated otherwise, given the strategies of the other players, no player can change their approach and increase their payout. Nash equilibrium represents a state of strategic balance where each player has found their optimal strategy. Given the choices of others, reaching a Nash equilibrium is not always straightforward, as the interactions between players can be intricate and interdependent. Finding Nash equilibrium is crucial for understanding the potential outcomes of simultaneous games, as they represent stable points where players are unlikely to deviate from their chosen strategies. Finding the prevailing strategies is the first step towards analyzing a reward matrix. For a given player, a dominating strategy is one that consistently outperforms all other strategies. Independent of the other player's decision, a player should always select their dominating strategy if they have one. We can search for Nash equilibrium if there are no dominating strategies. Collection of tactics, one for each player, such that each person's approach is the best way to counter the strategies of the other players. This is known as the Nash equilibrium. The Battle of the Sexes is an example of a simultaneous game in normal form that showcases the intricacies of decision making in situations where individuals have conflicting preferences. In this game, a husband and wife, labeled Player A and Player B respectively, face the common dilemma of choosing what to watch on TV. Player A, an avid sports enthusiast, prefers to watch a sports program, while Player B, a devoted fan of variety shows, favors watching a variety show. The challenge arises from the fact that their preferences clash, and their enjoyment hinges on watching the same program. The payoff table for the Battle of the Sexes is as follows: Players A and Players B. Satisfaction levels are shown in each cell of this payment table as numbers between 0 and 2, with player A's satisfaction level being represented by the first number and player B's by the second. The payout table makes it clear that player A and player B have opposing tastes. Player A's high satisfaction is achieved when they watch a sports program, while players B high satisfaction is achieved when they watch a variety show. The Battle of the Sexes has two Nash equilibria, which represent stable points where neither of them can improve their payoff by changing their strategy, given the strategy of the other player. The first Nash equilibrium occurs when both player A and player B choose to watch the sports program, resulting in both parties receiving a satisfaction level of 2. The second Nash equilibrium occurs when both player A and player B choose to watch the variety show, resulting in both parties receiving a satisfaction level of 1. The Battle of the Sexes highlights the challenge of aligning individual preferences with collective satisfaction. In situations where preferences diverge, finding a common ground requires compromise, communication, and a willingness to consider the preferences of others.